All right, 12.2. Number 2. The formula is 6n plus 3. 6n plus 3. And what they want me to do is find the first 4 terms. So let's do it. 6n plus 3. If I do n equals 1, n equals 2, n equals 3, n equals 4. Can you find those first 4 terms? So go ahead and plug in 1, 2, 3, and 4. Find the first 4 terms. And then they want you to find out what the common difference is. Like, what is the jump from term to term? Get 9, 15, 21, 27. Getting those? And what's the jump? How far from term to term? What's it going up by every time? It's adding 6 every time. That's the common difference. It's the jump from term to term. Notice, remember, math is a science of patterns. So observe the pattern with me. How could we have looked at this formula and predicted that the common difference would be 6? Well, it's the coefficient of n. It's the number multiplied by the n, isn't it? That's going to be the difference from term to term. This is what we call an arithmetic. This whole section is arithmetic sequences. And when I say arithmetic, what do you think? Adding, subtracting, right? Wasn't that the first thing you did when you were in grammar school, in elementary school? You did arithmetic, you added and subtracted. So these are arithmetic sequences, meaning from term to term you add or subtract the same exact number every time. There's a common difference. If you're adding the same number from term to term, that's an arithmetic sequence.
So say if it was like going from 15 to 9, would the common difference be negative 6?
Negative 6, yeah, you'd be subtracting 6, yeah. All right. Okay, so our formula this time is 6 minus 8n, right there. So same thing, they want the first 4 terms. Find the first term, second term, third term, fourth term. Find the first 4 terms. So 6 minus 8 times 1 minus 2. 6 minus 8 times 2, 16. Minus 10. 6 minus 8 times 3 minus 24. Is that minus 18? Yeah. 6 minus 8 times 4 minus 26. Good to there? And so what's happening from term to term? What's being added or subtracted every time? Yeah, minusing 8 every time, huh? So that's the common difference from term to term.
How come they use a different...
Oh, that just means set.
Okay.
That means the set containing everything that formula produces. Curly brackets just mean the set of. Good on that?
So when we see those branches, we think sequence, right?
Well, that can be a set of all kinds of things. That just means a collection of numbers. Just means a collection of. We're a collection. The collection of m4b students and Tuesday, Thursday at 11 o'clock. So just a collection of. That's all those curly brackets mean. So in this case, it's a collection of numbers in a sequence. But it could be a collection of letters. It could be a collection of anything. Okay. So they're saying on this one, A1 is 6. D is 2. Okay. Bless you. All right, so what do they want us to? Well, what does A1 mean when it's in a formula? You getting the hang of it. You're starting to, I know it's coming at you fast here, huh? All Are you speaking this language okay? What does A1 mean when they give me A1? First term. Everybody good with that? A1. So remember, again, the subscripts, the numbers lower down, are always the addresses. So this is saying, who lives at the first house is 6. It's like, who lives at 6380 is Heron. Right? Who lives at the first house is 6. So 6 is my first term. And then what does the D mean?
How many houses you're going? That's like the space between, right?
D means the jump from house to house. The difference from house to house. So the jump is add 2. So what's the next house? Who lives at the next house? 8. So that's the second term. So this is the first term. This is the second term. What's the next one? 10. Just add 2 every time. This is the third term. Right? We good? You get that this is add 2 again. This is the fourth term. Now what term do they want? We'll go get it. Which one do they want? What term do they want? $41st. Ready? Let's race. Ready, go. No, I'm just kidding. I'm not going to go. You're probably not either. We don't want to go that way, do we? You know what? We would like to jump right to the 41st term, wouldn't we? Wouldn't that be much better? I mean, we could get there one at a time, but that'd be terrible. And especially, what if they ask me for the 790th term? You know, that'd be really terrible. So, I want to be able to get there like a CD and not like a cassette tape. Do you understand what I mean?
I don't know. Some people might not.
They might not know, Matthew. You and I know, man. But you guys remember cassette tapes? Is that before your time? My kids laugh at me. My kids say, "Yeah, technically, because they'll say, video games when you were a kid. What was that? Come on, black and white."
How old are you? Oh. I cannot believe you guys don't know what a cassette tape is.
So, remember cassette tape, if you got your favorite song at the end of the cassette tape, you got to fast forward through all the other stuff.
And hope that you stop. And then I remember then it was cool just to see.
This is a cassette tape.
The what?
Oh, yeah, I know.
No, I never.
Like rock,
where you
like a little.
Okay. With a cassette.
This is a
It was like
cassette
cassette
tape.
fast forward, then they had like a.
This is
I
a
never
cassette tape.
experienced that middle phase.
Oh my god.
And then CDs, you jump right to where you want to go.
He said he's seen a cassette tape at an art gallery.
Well, you know what?
Killing me.
My dad had an 8-track.
8-track.
Yeah, in his car and in our boat, he had an 8-track. That's
My daughter asked me what a VCR was the other day.
yeah.
Oh my, thrift stores.
All right,
Oh my goodness.
we need a formula. Yeah,
Love it.
it's an artifact
I never
now.
thought I was old until today.
There's our formula that'll allow us. That's our CD formula.
I'm young, but
It'll allow us to jump like a CD right where we want to go. All right, so
the cassette tape. That's so.
how do we do that? Let's use that. So if we want to find, what do we want to find? The 41st term.
It's basically saying you can't stop it.
Here's the other thing I want to help you with. This number, 41st, it's an ordinal. Let me write that word for you. It's an ordinal number. What that means is it implies an ordering. What do I mean? It's not 41. I think that is. It's 41st. That's different, huh? I say, hey, there were 41, whatever, yo-yos in the store. Or if I say, my friend who ran in that race finished 41st, then that implies an ordering, doesn't it? That's different than just the number 41. 41st implies they were in order. That person was 41st. So whenever you have ordinal numbers, that's always in. That's the thing that confuses people. So once I started saying that years ago, I started helping people. So remember, the ordinal numbers are always in. That's always your in. Because it gets confusing. Which one's the address? Which one's the actual number? That's what messes people up. So remember, the ordinal numbers, the numbers that have like 5th or 7th or 42nd, those kind of ordering numbers, that's always the address. That's the in. Okay, so when you read that, you go, oh, they want me to do in as 41. That's exactly what they want you. So make that in, 41. What's a sub 1 then? A sub 1? That's the 6, huh? That's my first number. What's the n? Well, we already said that's 41. And what's the d? The d is the 2. It's the difference from term to term. That good? So now we can do it. 6 plus 40 times 2. 6 plus 80. 86. So we're able to jump to the 41st term. It's 86. Now, maybe some of you guessed that already or can kind of tell that was going to work. The only part that might throw you off is the n minus 1. Let me explain why this formula works and why the n minus 1 is necessary. Think about if I have a frog sitting on a lily pad. I'm going to do some jumping from term to term, from lily pad to lily pad. What if the frog is sitting on lily pad number, I can't draw, so I just write F, frog. So if the frog is sitting on lily pad number 1, and he jumped once, jumped twice, ending up on lily pad number 3, think about the numbers there, watch the pattern. How many jumps and what lily pad is he on? 2 jumps to get to lily pad 3. Notice the number of jumps is 1 less than where you end up. Because you started at 1. So 2 jumps, you're on 3. Right? If you want to get to lily pad number 4, how many jumps to get to 4? 3 jumps. 3 jumps get you to 4. So my point is that's why there's n minus 1. Because there's always 1 less jump than where you want to end up. So if you want to end up in the 41st term, the 41st lily pad, 40 jumps. That's why we do take away 1. We have 40 jumps of 2. Right? Each of the jumps is add 2, add 2, add 2. 40 jumps of 2 starting with 6. That was your first term. Start at 6, jump. Start at 6, jump by 2 40 times. That makes sense how that formula is working? It starts you at the first term. It says take n minus 1 jumps of distance d. That's why that works. So that'll let you jump like a CD right to where you want to go.